Hello and welcome back to the Redstone Engine YouTube channel. If you're wondering where the triple devlogs have gone, I'm gonna be temporarily putting them on hold because it doesn't give me the opportunity to make things like this. So can't look at it for too long. That's the whole project and video that you'll see. But yeah, so why have I decided to make like a little engineering project? Well, I've always wanted to do engineering. It's just really excited me, and I just decided, you know what? I'm gonna do it. I've always held myself to like, I don't want to make a project, or I don't want to start a project or learn something if it's not useful in some way. This project, it's not useful. It's a really silly, random thing, but you know what? What I'll get out of it is I will learn how to do engineering, and plus, I'll probably be able to do a lot more of these. So now, welcome to how I made a project with a spider bot. Enjoy. Roll the clips. It's a bit awkward going out in public and recording. But yeah, I'm actually really excited to start working on it. I'm currently gonna head over to a kind of study location because it avoids any distractions. I'm gonna try and get a lot done and hopefully be on track and on time for what I want to do. So yeah, let's see what I can get done. What work have I finished in the time that I had? Not much. So what am I creating? Well, this is kind of the inspiration here because I've had this kit before, and I thought it was really cool, and I was like, yes, this is gonna be my first engineering project. So I actually found this low quality video here, which I don't know, it's only like a few seconds that you can see. There's a few of them. But you could kind of see it walking a little bit there. But yeah, so I looked at that, and of course, how am I going to control this? I'm going to use an Arduino. The next thing to kind of think about is servos, or what's making it go forward. And then the next thing is, you know how it moves, you know how you're going to control it, how are you going to create basically the base or the structure of it? So I'm going to actually do laser cutting. I've also been doing laser cutting as a part of DemoBots, the committee that I'm in, and I just really like laser cutting. I'll show you like a little piece that I've made before. So I'm gonna use these servos, and there's something about it is how am I gonna have the pivot? So I just kind of looked up pivoting, and there's this project here that has pivots in a laser cut file, and I think if I go down to the bottom here, yeah, they use M3 machine screws with washers and lock nuts, so I'm gonna look for that. I'm gonna order that as well to make sure everything's kind of there. And just kind of thinking about all the stuff that I kind of want. A stretch goal is to actually use some sound sensors to kind of turn to what you're hearing. I think I was always interested by a project that you could do with like the Mindstorm robots where like you could have the sound sensors detect like, oh, the person's over there, so it heads right and things like that. And so finally I started the fusion file, and I cut the M, and that's all that I was able to do today. I honestly planned on doing like a whole lot more, but just at least starting and breaking this project down has really helped me kind of find motivation to continue working on it and to basically get this all done. And yeah, hopefully I've explained the project and we can kind of get into it now. Alright, packages have arrived. Yeah, I got them all shipped, and now we need to see what's inside them. So I'm gonna open this up, probably not with one hand. Alright, cool, got a bunch of whole tiny boxes. I got the servos, sound sensors, washers, wires, battery cases, batteries, screws, and in here I have toothbrushes. Now the toothbrushes are very important for the spiderbot because these are actually going to be the legs. It's not actually, I just needed toothbrush heads for my toothbrush, so I'll put that to the side. Okay, so I have all the stuff here. Sorry for holding the camera at weird angles, but I'm trying to get used to it. There we go. So I actually need to do, like, you could see the model that I had for day one. It was not ready at all for production. So I'm going to want to get started on that now, and we'll see how much I get done with that. I actually want to try and get a physics test done in Unity through the model that I get through Fusion. So yeah, let's get into that. Alright, I'm back. It's actually been a little while, so you can see here, this is Unity. This is actually kind of doing a Unity test of kind of the model. I went ahead and kind of had a basic extrusion of all the parts to do kind of all the connections like this. Let's go ahead and hit play, and you can see that it will move forward. It sort of leans a bit, which is a bit worrisome, but the important part here is that just this random sketch that I did, you can see he's leaning, it works. So if I end up changing the measurements, which I did have to change the measurements, and also the weight distribution, it should pretty much work. There he goes. Oh no. Okay, so now heading over to Fusion, this is what has taken me the longest part over here, and yeah, as you can see, it's pretty complicated. Let me actually open up the first sketch here. You can see those are a lot of measurements, those are a lot of numbers, and it's hard to actually keep track of everything. I've actually also done some testing on wiring things up, and I found something out. So like moving this servo here, it goes 120. This is something that I forgot to check. This is a discrete servo, not a continuous servo. And as you can imagine, looking at this thing, I don't want a discrete servo that only goes for like 5 inches. I want it to be able to continuously run, but it stops at about like 120 degrees. So I thought, well, what's stopping it? So I ended up opening it up. I've actually modified it for this one in terms of opening it up, and you can see that it's now continuous, because the thing that I'm trying to do is I have all the materials here and I'm working with what I have. What else have I forgotten? Oh, these screws aren't as long as I thought they were gonna be, because as you can see, I've laser cut before. This is my proof. The board's pretty thick, and it can only go through, I think, like 2 layers about. It can go through 3 layers, as you can see for, gotta resituate. As you can see for this part here, it'll need to go through 3 layers, but for this hole here, I'm actually going to have it a bit smaller. As you can maybe see, yeah, a bit smaller, to where hopefully I'll be able to thread it in there. Oh yeah, that's the other thing, is that I don't have wood glue either. So what I have to do is I have to clamp it down using friction fit for this piece to make sure that it's not easy to slip off, but it's not impossible to put on. So yeah, I'm working with what I have, which is kind of exciting. I kind of enjoy doing this. But what I could do, or what I am going to do, and how I'm going to actually laser cut all this, is I have the one here, and then I go drawing, create new, and bam. Hold on 1 second, and bam. So now that I have all this here, then what I can do is I can just export as a PDF. I'm gonna open up where's laser cutting, import image drawing, vector, and bam, it's right here. But yeah, so now the task is just putting it through here and getting it all ready to be laser cut later. So I will see you then. Alright, coming back after laser cutting. I'm harboring the goods. I actually did within the last 30 minutes that they were open, because I also had a demo bots meeting at that point in time. But yeah, I went to my makerspace. If you don't know what a makerspace is, I would definitely recommend trying to find if one's near you. The one wasn't near me in my hometown, but towards the last couple years of my high school, high school started kind of my robotics club. Started having more of a makerspace with like 3D printers and things like that. So yeah, progress is going good. Hey, welcome. So I have all the parts here. I'm gonna assemble. So you can see, wow, these aren't all the pieces. Bam, ta-da! I was smart about my space, which was good because I didn't have a lot, because I was using scrap wood, so I don't need this piece and this piece. don't need them. Okay, so here's everything. I'm just gonna build the whole thing, and then eventually I'll get to coding it. So yeah, it's a time-lapse time. Alright, welcome back. It's been about 2 hours and I've got all this done. Now I think I've wired everything up in the right position. That was because I tested the servos beforehand. My biggest concern is that it will fall apart because, as you can see, these are very loose. And I should have maybe searched for some lock nuts. The other huge issue is that I didn't check these at all. I took this from another CAD of a servo horn, but apparently the servo horns are different, and it wasn't the right shape. So I've as you may have seen, I've just been using a box cutter to kind of shave away this side to actually fit it on, and it works. If I turn this here, you can see that it moves if I kind of do that. So yeah, I'm gonna have to do the same for this one, and this one took a while to actually get to where it's at. But yeah, it all works really good, and I'm super excited for that. Like, wow, that's amazing. So I'm gonna finish this, and then I'm gonna code, and yeah, then I'll try and get some friends to see what they think of it. And this is where disaster strikes. So yeah, there's a lot of issues. I think I talked a bit about them before. Problem is that this servo is now completely dead. It's hard to turn it either way. It's also hard to turn it if this leg is in this position here, but which I don't completely understand why. For actually this servo over here, I also turned it into a continuous servo, but I opened up this one a lot more. But for this one, I didn't really touch it, or I didn't mess with the grease or do too much fiddling with it, so this one's completely fine. So, you know what? This video may take another month to make, but I've ordered some electrical tape for an electrical problem and lock nuts. I'm also going to modify another servo, and then finally, I'll have a cool looking robot. The bot's all finished. It's been made. This little spider bot took a lot longer than I expected, but you know, it was a very fun project to make, and I mean, I'm glad I designed and made this entire robot and like laser cut it and all, and I'm really excited to do some more projects. You should definitely leave a comment of like ideas for projects, and then even if I don't do them, maybe it'll inspire someone else who's looking through the comments, like, oh, you know what, that comment that someone else said sounds like a pretty cool idea. So yeah, I'm gonna go and share it with my friends and see what they think about it. Alright, we got the first person reacting to this bot that I've created here, and it's Test Your Mind. Yep. Alright, this is Kristen, also known as Ivy Walker, and today I'm gonna show her my robot that I have here. You haven't seen this bot that I've made, right?
No, I have not.
Okay, yeah, you're gonna see it for the first time here. Alright, this is it.
Quite intuitive.
Yeah.
It looks like you kind of just bought it at the store.
This is it. That's my, it's my robot. Feel free to interact with it. Just, you know, be very delicate. It could explode. So obviously this isn't the actual robot.
Could you attach the plastic to it?
This is the actual bot.
Oh, when you said you built it, you built it.
Did you want to see it go?
No.
Okay, well that's it. Now it's gonna attack you. You're gonna die.
Oh wow, it's happening so fast. I can't believe it.
So I'm just gonna turn it around so it doesn't attack you. I know you're afraid there.
Yeah, I thought I was gonna die.
Should I give it a target?
Yeah, definitely.
Will it hit me?
Sure.
High five. High five. It's a friend.
Yeah?
Oh, wow.
Yeah, and it has sound sensors here, so if they detect a sound, it turns.
Oh, I played with those in electrical engineering.
Oh, yeah.
Yeah, we made a radar. So whenever I did my project in my electrical engineering course, we made a radar.
Yeah.
That scans left and right like this.
Yeah, so like a submarine?
Yeah, like a submarine sonar. So this is kind of similar to that, but a little bit different. It takes that information and goes towards it.
Yeah.
So that's really cool though.
I'm still noticing the walking pattern. So it seems like it launches the legs forward,
Yeah.
and the middle legs propels it forward.
Yeah.
Ah, so it's like a perpetual motion.
That's not how perpetual motion machine works.
Why did you refer to him as Spiderbot when he has 6 legs?
Man, I was hoping nobody would notice.
What's a bug
Yeah.
that has ant but doesn't look like an ant?
Yeah.
Beetle? I'm assuming this takes in all the info from the sound signal.
Yeah. So an Arduino is essentially have you ever heard of an Arduino before?
From a Michael Reeves video, he said the word, but he doesn't like to explain things.
Yeah. So the Arduino, it's essentially just like the brain of it. So essentially I can connect it with the USB port here into a computer, and I just program it some instructions.
What made you decide to point him in this direction instead of right in front of him?
Well, so they have 2 of them, so it's essentially just
It's just the field is like this.
yeah, because there's sound sensors. It was supposed to be following your voice, but the thing is the servos are so loud that it doesn't really work that well, and you have to tap them
Oh, okay.
for the sound to actually go
You
through.
have to tap them.
Yeah, and that's also why I kind of dampened these to try and get the sound to go across.
Those are 4 AA's?
Yeah. So this each AA battery is 1.5 volts. If you 1.5 times 4, that's 6 volts.
Sure, I believe.
And both of the servos required 6 volts to run. And this is only 9 volts, so it wasn't enough, and it's recommended to use to separately power it.
So this is all very tight, nothing's gonna fall off.
Yeah. Yeah.
Let's put it to the test.
This is simulating a magnitude 42 earthquake.
Oh my god. It survived.
Do you know how much weight this can support on top of it possibly?
Oh, I don't actually know.
How much weight would you put on it before it stops moving?
Well, we can do a quick test. All right, weight test number 1.
Weight test number 1. It's hold on.
It doesn't really have a space for weight, but
I mean, it turns with the
yeah.
16-ish ounce water bottle.
So this is the new mode of transport then.
Oh yes, this is the new mode of transport. Spider transportation.
Spider transportation.
Sure.
Can it crawl on my hand?
Sure. Do a little crawling test. Because I've only ever tested on flat ground. It's an all-terrain vehicle.
It tickles.
I don't think this is what it was made for.
It's biting me. Wait, so what's the light switch for?
That's just a decoy.
Did you just buy a light switch?
I don't know, man. This one's kind of stolen my heart.
Yeah.
I will be taking this.
Wait, what?
No, yeah. I'm stealing this and I'm gonna pitch it to Shark Tank.
Oh yeah.
Under my alias, Joe.
Joe.
Yeah, and I would be pitching them this as a STEM toy for children.
Have you felt it at all? Wow. I just gotta test your mind. Hand reveal.
Just feels like wood.
What's its name?
Its name is Spiderbot. That's like its official name. It doesn't really have like a personal name to it.
Can I name it?
Sure.
Carlos.
Carlos. The Spiderbot's name is now Carlos.
My other question is, since it's supposed to follow sound, if it ever wanted to run away from
It hasn't been programmed to run away. It's just all offense.
But what if it decided it wanted to run away?
It can't. I've programmed it to have no fear.
Pretty good.
Oh no, it's attacking me.
No, you haven't.
Yeah, I have been programmed to not feel fear. Alright, Carlos and me are back. Just went through a little, I don't know, interviewing spree. It's pretty decent. They actually really enjoyed it. You know what? For the sensors, my backup plan was to have it stop so the servos would be off so it wouldn't be making a sound, and then it would like detect the sound, but he'd have to like stop every few seconds, and he's already pretty slow. And like, if you can imagine, like if a killer's coming at you with a chainsaw, then he has to stop every few seconds, turn off his chainsaw, listen to you, and then slowly approach again with his chainsaw. It's just, it doesn't really feel that productive. But I mean, I guess his following technique is more of like a, oh, where's the sound? I want to join in and things like that. So yeah, Carlos, do you have anything you want to say?
Help, I am trapped. Please comment and subscribe to free me.